Hello everybody. Now in this session today we will be starting with properties of absolute value. In the previous session we have learned the basics, definition of absolute value, and that told us that it is nothing but a non-negative quantity, and two graphs we studied. Now let us start with absolute value properties. For real numbers a and b, we write absolute value of a as a non-negative quantity. This we have already seen in the last lecture, so obviously this is very trivial thing to understand. Now in case I take a number which is nothing but 0, then what will happen? Since that number falls on 0, so its distance from 0 would be 0. So we write it as absolute value of a equal to 0 if and only if a is 0. You can all see that I have written here IFF for if and only if. So in mathematics we use at times some short symbols instead of writing long or big things. So IFF stands for if and only if. At times instead of IFF we also use two-sided arrow and it is read as equivalent to. So I would have read it as absolute value of a equal to 0 is equivalent to a equal to 0. What it means? That if I take number 0, its absolute value is 0, or it is other way, that if absolute value of a is 0, then that number must be 0. Now let us move to third one, which says that absolute value of AB, the product of two numbers, is product of their moduli. Now I have used word moduli, which is nothing but absolute value in case of real numbers, and this was most expected or intuitively understandable thing to happen, that absolute value of AB is product of absolute value of A and absolute value of B. Let us take fourth one, triangle inequality. As name suggests, it has got something to do with triangle. Now recall triangle inequality, what we have learned in case of our plane geometry. We have seen that sum of two side lengths is always greater than third side. And here absolute value is nothing but distance. So we should be able to correlate to, we write absolute value of a plus b less or equal to absolute value of a plus absolute value of b. Now please concentrate on the sign written there, less or equal to. Equal to has some importance in case of inequalities. Here what we are trying to say is absolute value of a plus b can never be greater than absolute value of a plus absolute value of b. Also we are emphasizing on the fact that absolute value of a plus b will have the highest value as absolute value of a plus absolute value of b. Means greatest value can be achieved when we are writing less or equal to. Now when does that equality occur, we have to understand. Now let us take two numbers a and b. If I take a as 7 and b as minus 3, what will happen to a plus b's absolute value? It would be 4, and absolute value of a plus absolute value of b is nothing but 10. So actually what we have found is 4 less than 10. So equality has not occurred. So there should be some standard rule to understand when does equality occur. Now equality occurs when a and b have same sign, or one of them is 0, or both are 0. Now one of them 0, both are 0, that was quite intuitively true. But a and b having same sign will give us the equality, can also be checked like what we checked before by taking two different numbers in place of a and b. And this all, that a and b have same sign, a or one of them is 0, or both are 0, can be written together in one statement as equality occurs when AB is greater or equal to 0. This result is extremely important, which we will be using in other chapters also. Now let us extend these properties and take few more. Now what happens to absolute value of A? Obviously it would be absolute value of A. Why do I say that it is obvious? Because outside absolute value notation needs to be eliminated or rejected because inside quantity is non-negative, and whenever it is non-negative, we need not write that absolute value notation. Now, next is absolute value of minus a. Now, intuitively, I know the answer if I remember the distance concept, that it has to be absolute value of a. Now, how do we arrive at that result? That absolute value of minus a can be rewritten as absolute value of minus 1 into a, and using that property of product, we can write it as absolute value of minus 1 into absolute value of a. And then what will happen next? Absolute value of minus 1 is 1, and it reduces to absolute value of a. Now, absolute value of minus a equal to absolute value of a. This I have tried to derive, which was very much clear actually had you drawn the number line. Now, absolute value of a minus b equal to 0. What would it lead to? Intuitively, I know that a and b have to be same. You can check yourself by taking different numbers, and you will realize that absolute value of a minus b turns out to be 0 only when you take two equal numbers. Now, absolute value of a minus b can also be written as absolute value of a minus c plus absolute value of c minus b. Now, this again looks like the triangle inequality only, that we are trying to write absolute value of a quantity less or equal to sum of two different absolute values. Now, which is seen by taking a minus c as x, c minus b as y, and we find x plus y is nothing but a minus b. And the result is very much obvious. It is nothing but the extension of triangle inequality. Now, let us move to next. Like product, we have rule for quotient also. That absolute value of quotient of two numbers is quotient of their absolute values. Now, next property, absolute value of a minus b greater or equal to absolute value of difference of two absolute values is quite again similar to triangle inequality, and this also takes our attention because of that greater or equal to sign. Now, this again tells us that we need to search when equality occurs. Now, since two absolute values are included there, absolute value of a and absolute value of b, by taking two different signs for a and b, we will find that we will get strict inequality, and only when a and b have same signs, we will be finding that two sides are equal. That means equality occurs only when a and b have same sign. Again, like previously, that one of them is 0 or both are 0. Now, this is about absolute values. And one more extension we can take as absolute value less or equal to b. And this suggests me that we will be taking case as absolute value of a greater or equal to b also. And both are derived on the similar lines. Now, since absolute value is involved, we will be going by strictly definition. We write a less than 0. We will be replacing that absolute value of a as minus a, and we arrive at minus a less or equal to b. We want condition on a, not on b. By writing minus a less or equal to b, I am getting condition on a. So, I multiply by minus 1 on both sides, and inequality sign changes, and we get a greater or equal to minus b. One condition I have found, in case when a is negative. Now, I go for next, and now take another case, a greater than 0, and that absolute value of a less or equal to b will be nothing but a less or equal to b. So, this was quite obvious, simple to write, and we have found now two constraints on a, that a is greater or equal to minus b, or it is less or equal to b. So, whenever you find here onwards absolute value of a less or equal to b, you can write free of that absolute value notation of those two vertical lines and write it as minus b less or equal to a less or equal to b. Now, absolute value of a greater or equal to b, we exactly start on similar lines. A less than 0, replace that absolute value of a by minus a, and we will be getting a less or equal to minus b by obviously again multiplying by minus 1 sign. And if a greater than 0, no changes to be made. So, absolute value of a greater or equal to b would be simply written as a greater or equal to b. So, we have achieved now two conditions. A less or equal to minus B or A greater or equal to B. Now these two results we will be using when we go further to next topic, inequation, in our further sessions. Till then, stay tuned. Bye. Thank you.